So we've been talking a lot about angles, which is one of our primary ideas. Another about segments rather. Today we're going to switch to angles, which is another primary idea that we'll have, and we'll use those two things to make various shapes. So an angle is a figure composed of two rays. Those are called the sides of the angle, with a common endpoint called the vertex. So in this diagram, with this angle, ray TR and ray TS are the two sides of the angle. When you name those, you must name T first, like T for Terrence. There he is. All right, so it has to be the vertex first because it's starting from here and it's going this way. It's not going the opposite direction. The vertex is the point where the two rays meet each other. So that's T. For this angle, we can call it angle RTS or STR or, and I apologize for the typo here, please change that to angle T. Now, you may be wondering, well, why do we name it those ways? Well, first of all, let's start at the end. Angle T. How many angles in this picture have their vertex at T? There's just one. There's only one angle in the picture. So when we say that, we're saying the only angle with a vertex at T. When we're saying RTS, notice if, you don't need to do this, but if I start at R and I draw to T and I draw to S, have I drawn most of the angle? Yes. Or if I start at S and go to T and go to R, I've drawn most of the angle. That's why those are named the way that they are. So, if you have an angle on a plane, which means if you drew it on a piece of paper, that's like a plane. Every point in the plane is in one of three places. It's either on the angle, that is, it's on one of the sides or at the vertex. It's in the interior of the angle, anywhere in between the sides of the angle, or it's in the exterior. So here's a diagram, and I've shaded in part to make it clearer, I think at least. For triangle MLP, notice I go from one side to the vertex to the other side. Ray LM and LP are the sides. You have to start at the vertex and go out from there. Points M, L, and P. Notice there's not a big dot for L, but we understand that when those two rays touch each other, they touch each other at a point. Those are all on the angle. Points N and Q, because they're in between the two sides, are in the interior of the angle, and points J and K are in the exterior of the angle. They're outside. So if I had a point here, you don't need to draw this, but if I had a point here, and I called that S, where would that be? Interior, exterior, or on the angle? It'd be in the interior. It's in between, because these two sides keep going forever and ever. Amen. So it's anything inside of there will be interior. Okay? It's not just what's inside of this one curve that I drew. All right, page 2. So, let's practice this. I want you to see if you can answer these first two questions and then do what it says in the third one and answer the fourth one. I'll give you a whole minute. I'll probably give you longer than that. All right, I know you may not be quite finished yet, but let's see how you're doing. Anybody who wants to just shout it out, what is the vertex of angle BGD? G. Yeah, exactly right. Good. Heard lots of people. All right, the sides of angle FGE. So that's this angle down here. There are two sides. I need to do one at a time on this one, so if someone will raise a hand, they can either give me both or... Yes. Max, you do. Unplug. Go ahead.
GF and GE.
And what are GF and GE? What kinds of things are they?
Rays.
Yes, they are rays. Very nice. Ray GF and Ray GE. Make sure that you put the arrow over it to show that it's a ray. All right, shade the interior of AGE. The interior of AGE would be all of this. Everything in here is in the interior of AGE. All right, what point or points lie in the interior of EGB? Let's see if we can get some other people involved. Yes.
C and D.
Yes, absolutely. C and D. C and D are in the interior. And then a question for you. Why do you think we can't name any angle in this diagram angle G? Yes.
Because it's in the middle of everything, so every point needs to like remove it.
So what do you mean by that? I think you have the right idea.
Because it's like G is in the middle, so then if we try to make a point, it would have to be CGC. Like you can't have a point if G's in the middle of everything.
Well, you can have a point. G can be a point and is. Max, you have a thought? Oh, okay. Yes?
Does it have 2 points? It's just one.
No. Sydney, what do you think?
Maybe it's the vertex.
So is it the vertex of just one angle? It's the vertex of a whole bunch of angles, right? So if I say angle G, would you know which angle I was talking about? No. It'd be like if I had a class where I had two people who had the same name and I just called their name. Nobody knows which one I'm talking to, right? So that's because there is more than one angle. With its vertex at G. Or you could say that all of those angles have their vertex at G. Now, for measuring angles, in this class, the measure of an angle is a number between 0 and 180 that tells how much we would need to rotate one side of an angle to get to the other side. For this class, that's always going to be in degrees. For those of you who take pre-cal eventually, you'll find that there's a completely different way to measure angles. And at first it feels really weird because you've done degrees for so long. But let me ask you a question. Why are there 360 degrees in a circle? Or why is a right angle 90 degrees? Who decided that?
I don't know.
Math people.
It's just made up. At some point, and historically, I'm trying to remember if it was Babylonians or some other group. Anyway, they had a numbering system where 360 worked very nicely for them. And it was close to the number of days in a year. They knew it wasn't the number of days in a year, but it was close. And that's why they used it. It's randomly picked. Okay? And we're kind of stuck with it, but it works out really nicely for most things. When you get to pre-cal, you'll find it's like, it doesn't work so well for things in calculus, and so you learn a different way to measure angles. But we won't worry about that right now. So, there are two special benchmark angles that we use to divide, that should say angles, into classifications. First of all, there's the right angle. The measure of a right angle is 90 degrees. Symbolically here, we want to say the measure of this angle, we write that little M in front. That little M in front says the measure of this angle is a certain number of degrees. We also have straight angles. The measure of a straight angle is 180 degrees. And sometimes students go, well, isn't that just a line? Yes, a straight angle makes a line. But you would have to rotate one side 180 degrees to get to the other side. Okay? You're halfway around a circle. For this form of geometry, we don't do anything bigger than 180. Fact is, they say there's no such thing as angles bigger than 180. Again, when you get to pre-cal, you'll do angles that rotate around and are, 800 degrees and stuff like that, where they spin around and around a couple of times. But that's for a later day. So, two terms that you do need to know. We don't use them a lot for problems, but we use them a lot to describe things. An acute angle has a measure less than 90, and an obtuse angle has a measure greater than 90 degrees. So this is an acute angle, and this is an obtuse angle. And I don't think I pointed this out, but you probably figured it out already, I hope. That's the symbol for angle. Be careful, don't make it a less than sign. An angle sign, the bottom part is horizontal. Okay, so this is an acute angle and an obtuse angle. And in geometry, we have to write a fair bit, so we're going to abbreviate a whole bunch of things, and we're going to use symbols for a whole bunch of things, so we don't have to write as much. All right, most of that should be review of things that you've known for a long time, right? So now let's go on to page 3. Congruent angles. Now remember, we talked about congruent segments earlier. Congruent segments were segments that had equal length. Well, congruent angles are angles that have equal measure. Remember, the idea of congruent is put your hands together palm to palm. One pretty much exactly covers the other one, right? That's the idea of congruent. Every time you think about congruent, I want you to think about that. So for angles to be congruent, well, they're all kind of the same shape. To make them the same size, they need to be the same measure. So here, since the measure of angle CD is C is equal to the measure of angle D, angle C is congruent to angle D. Notice that when you have measure, that goes with equal. When you just have the angle without the measure, that goes with congruent all the time. Because here we're talking about objects. Objects are congruent. Numbers are equal, and the measure of an angle is a number. So we'll never say the measure of angle C is congruent to the measure of angle D. That doesn't make any sense. All right. So on your test, you did ones where on a number line, you found the length of a segment by subtracting the two coordinates. We can do something very similar to find the measure of an angle. Let's take a look. You don't need a protractor for this class, by the way. Sometimes students are like, do I need to buy a protractor? No. We're going to use it a very little bit here at the beginning, and that's going to be it. Logan, you with us?
I am.
we're on a different page. Notice there's two different scales on this. There's an inside scale and there's an outside scale. One of the cool things about this is, for each problem, you can pick whichever one you want. It does not matter. So for every one of these problems, we can pick whichever scale you want. So let's look at the measure of angle DXA. So I'm going to make this a little bit bigger. Just like we did with segments to find the length we just subtracted, we can do the same thing here. So let's say I decided to use the inside scale. If I'm using the inside scale, the A goes through 0, right? Ray XA. If I'm using the inside scale here, ray XD goes through the 160. So I can say, all right, just take 160 minus 0, and that's 160. I think that's the easiest way to do it. But we could also use the outside scale if we wanted to. On the outside scale, what does ray XA go through? 180. And over here, what does XD go through? 20. It doesn't matter which way you do it, you get the same answer. Please make sure you're always doing the bigger number minus the smaller one. In this class, angles never have negative measure. Again, when you get to pre-cal, there are angles that do have negative measure. Just so you have things to look forward to. So here, if we're trying to find the measure of AXC, pick a scale. It doesn't matter which. Let's do the inside first. So ray XA goes through 0 on the inside and through 110 on the outside. So that's 110 minus 100, oh, excuse me, minus 0. Sorry, I was thinking about something else. Is 110. What if you use the outside? As long as you use it for both, it's okay. XA goes through 180 and XC goes through 70. That's also 110. All right, see if you can do the next one on your own. Bless you. All right, the one thing that's sometimes hard for people on that one, for BXA, is reading this over here where it doesn't go exactly through something that's a multiple of 10. If we're reading the inside scale, XA goes through 0, and XB is somewhere between 40 and 50, and you go out here and it's 1, 2 marks away from 40, so that's 42. So this would be 42 minus 0 if we use the inside scale. Or, and you don't have to do both, I'm just showing you it works. If we do the outside scale, XA goes through 180 And this is where people sometimes get into trouble. They think that this is 142, but it can't be. It's between 130 and 140. So if you're 2 away from 140, where do you have to be then? 138. So we can do 180 minus 138. It's also 42. All right, let's do BXC. It doesn't matter which scale we decide to use. I'm going to stop doing both. I'm just going to pick one. I usually use the inside scale. I find it easier to read. So this goes through 110, and the other side, XB, goes through 42. So it's 110 minus 42 is 68. All right, please do the last two on your own. Feel free to check your neighbor to make sure they're right, because I'm sure you got it right, but your neighbor, I'm not so sure about them. Of course.
The last two.
Get the number on this side, and you get the number on this side, and then you subtract it, or you get the answer.
Wait, I don't think I clicked it right
This
this
one
one.
for probably take it
For the thing.
For the,
Cause I put 110 and after
No, the DXC?
Yeah.
Yeah, you were supposed to have, if you did the inside one, so I did the inside one, it would be 160 minus 110.
Which would be 50.
Yes.
Oh,
I got 18.
See, Jacob's so smart.
What'd you get for the last one?
He's the best at this class.
now I got 50 on that.
One goes away.
22.
When you subtract 100, it goes away.
What did you get for?
Oh, I didn't finish it. I'm still at it.
Tyler.
All right, I have written the correct answers up here. Please check yours against mine.
But that still makes the one go. Oh, okay, I got it right. I got it.
I got 8.
Pardon?
Can you do the second one?
The second one? Yes. Tell me how you did the second one. Shh, shh,
Oh,
shh,
I
shh,
erased
shh.
my stuff.
Yeah, I got
You erased it? Oh, hang on. Sorry, I did the wrong one.
Oh.
BXD. My fault.
like, reading mistake,
Did you get 118?
Yeah.
My apologies.
You died. He's gonna follow you.
Sorry if I caused you any consternation.
That's a word.
Consternation? Yes.
How did I only get 22?
All right. Are there questions about either of these?
The last one?
The last one? All right. So, shh. Langston, tell me how you did it.
So I looked at B and I saw that was 42.
Okay, so you're using the inside scale.
Oh, that's where I went wrong.
Did
I
you switch to the outside scale?
I did 42 minus 20 instead of 110. Instead of 160 minus 42.
There you go. So once you pick a scale, stay with it. Yeah, don't switch part way through. It's a real easy mistake to make. The other thing you can do this by kind of counting 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and this is another 8. You can do that also. Sometimes that's easier than others. Sometimes that can be a little confusing. All right. Let's go on to page 4. So, all the things we've been doing have something that's analogous or something that matches up with it from segments. We talked about lengths of segments, right? We were able to find its length on the number line, just like we're able to find the measure of an angle with a protractor. We had congruent segments. We have congruent angles. So just like every segment has a midpoint, every angle has an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So here, if ray XW, that's this ray here, bisects YXZ. When you think about bisects, I want you to think about someone took a cleaver and whacked it in two. That's exactly what's going on. It took that one angle right in the middle, bam, split it into two parts that are exactly the same size. Okay? Then these two angles are going to be congruent to one another. Angle YXW and angle ZXW. So since they're congruent, their measures are going to be the same. All right, so let's do some problems with that. Here, if ray AB bisects angle JAL, so I'm going to draw a picture that shows that. I don't know exactly how big the angles are. It doesn't really matter if you draw it exactly to scale. So my angle was JAL. And then grab a meat cleaver and slice it into two parts. And we know that the lengths of those, or the measures of those two parts, are the same. The way that we mark that, you know, with the segment, how we did a little slash across each of them to show that they were the same length? The way that we show angles are the same measure is to mark a little arc across each one of them. And I make them different sizes because if you don't, it looks like one big arc. So these two angles have the same measure. It's the same amount of rotation to get from L to B as it is to get from B to J. Okay? And then it tells me the measure of JAL is 84. Well, that's this whole angle. So if these two are the same and add up to 84, what's the measure of each one of them? 42. So on this one, they told you the measure of the whole thing. You cut it in half because it's a bisector. Bisect literally means two and cut, to cut into two equal pieces. So we just split it in half. This next one, not quite the same. Here it says if CD bisects angle ACB. All right, so ACB. Draw that angle. A on one side, C is the vertex, B is the other side. And CD bisects it. Grab your meat cleaver and split this in two. And not just in any two pieces, but two pieces that are exactly the same size. I cut it exactly in half. And it says the measure of angle ACD is 46. So what's the measure of DCB? 46. Those two are the same. Okay, any questions about that? Okay, then I have a worksheet for you for your assignment.